Hi everyone, I'm Shakti Perdana, physics teacher from BINUS School Bekasi. I would like to present our STEM classroom project, an artificial coral reef design. This project challenges high school students grade 11 to work in groups of 5 to design and develop an innovative artificial coral reef. Working collaboratively in groups of 5, students will leverage science, technology, engineering, art, and mathematics principles to create structures that serve a dual purpose. This dual purpose structure aims to function as both a wave barrier, safeguarding coastline from erosion, and a vital habitat for coral growth and restoration.
The outer ridges.
Oh, the outer. Drawing inspiration from nature, biomimicry, their imagination, or everyday object, students will utilize their creativity to design the reef's shape and structure. This project fosters a truly interdisciplinary approach. Students will gain a deeper understanding of coral reef biology and the threat they face. Employing cutting-edge 3D design software such as Tinkercad and Blender, they will translate their concept into visually compelling and functional models. Artificial intelligence (AI) will be utilized to gather crucial data on coral reef, identify suitable location in Indonesia for reef installation, and spark innovative design ideas.
Sort of like a vacuum effect.
Additionally, students will integrate artistic expression with mathematical principles like scaling and geometry to optimize the reef structure and maximize its surface area for coral colonization. Physics concepts will be applied to ensure the reef stability against various environmental forces. Through this project, students develop critical thinking, collaboration, research, and design skills, all while contributing to a potential solution for coral reef restoration.
This is our main idea or our main inspiration. It's based on the biological endoplasmic reticulum, and we choose this as you can see, it's kind of like similar to an actual coral reef in a way.
Okay.
And we also plan to use materials of terracotta, since based on our research, it has similar properties to coral reefs.
Okay. Good.
So you know how like when air passes over a mountain, it creates extremely turbulent air. So basically, I tried to make it the same design but underwater, so it'll help reduce and break the waves actually. So we ended up on the design of a staircase. This initial design was made by Pedro. He drew this. So we made this design so like the water will come up here, and these things will absorb the energy and it'll go up, so it'll also reduce energy.
Indonesia's irresponsible fishing activities and increasing pollution from factories and the like has led to the destruction of coral reefs. In Indonesia, gas emissions due to agriculture and industrial processes give rise to ocean temperature, causing coral bleaching, a phenomenon that caused the death of thousands of square kilometers of coral reefs. In fact, 30% of world's coral reefs perished in the last 15 years due to climate change and other human activities. So, our team, the Fish Keepers, have come up with Fish Hive, a solution that focuses on the SDG 14 goal, the conservation of marine resources for sustainable development. Fish Hive mimics a beehive, metaphoric to these reefs being home to marine life, like a beehive is to bees. AI has further supported our idea by saying that a beehive design shape offers some advantages for artificial reefs by maximizing surface area, promoting water flow, and creating a complex habitat structure.
By focusing on these specific goals, we came up with several initial designs. However, there are several problems that we encountered the shape of these initial designs, that is the structural integrity or strength of the structure. We decided to provide walls of protection for further shelter and for lessening the impact of wave pressure. With a higher surface area for cover, the force will be spread out, limiting the pressure received and reducing the risk of the artificial reef model breaking. This is based on a specific scientific formula for pressure. Pressure equals to force divided by area. After several tries, we ended up with these features for our final design. We decided to implement birequires to take advantage of a low, safe electric current. This electrolysis method allows for calcification and mineral accretion. So minerals like calcium carbonate form solid limestone around the metal electrodes. Calcium carbonate then attracts coral polyps, which are components of a coral. Birock method is also good for coral farming as it promotes coral growth rate by 4 times and helps injured corals by its ability to heal coral cell membranes. These wires are arranged in a layer pattern to create ground for friction for wave breaking.
It is built to break ocean waves while remaining friendly to the ecosystem and its inhabitants, as well as protecting coastlines from coastal flooding and other potential damages from the sea. We also decided to use geopolymer concrete as the base of our reef, as not only is it durable and has a rough surface for friction, but it also has a lower carbon footprint compared to normal concrete, which is used in a lot of artificial reefs. This conveniently aligns our design with SDG 13, climate action, as we try our best to reduce the carbon footprint of our design. Our design is also fitted with tunnels, which fish prefer, and holes, which crustaceans prefer, to give marine creatures a safe shelter to thrive, promoting biodiversity. Eventually, we came up with our final design, the Fish Hive. We tested our design in a fluid simulation and noticed how the water particles slow down after encountering the reef. However, we noticed that there is a deflection in the water wave because the height of the water that we used in the simulation is too shallow, only 1.2 meters. Meanwhile, we're going to implement our design on the seabed, which is around 30 meters deep in the ocean.
Our design was created so that it can be used by local communities, marine scientists, government, and most importantly, marine life. While the process of making the reef into a healthy and active artificial reef may take some time, this process is effectively sped up by the integration of biorock to our design, providing it with an advantage over other artificial reefs. In the future, we hope that Fish Hive can be a biodiverse habitat for thousands of species of marine creatures and become a great place for coral conservation and farming.
Hello, we are here as the Candy Crush Group, presenting to you the results of our discussion over the past few weeks. First of all, what are we tackling here? First problem is definitely coral reef damage, which is caused by destructive fishing practices, global warming, and reduction in water quality due to pollutants. Around 30.4% of coral in Indonesia's waters are actually damaged. Thus, this causes shoreline erosion, which is a huge problem, namely because the coral acts as a natural barrier to dissipate waves through friction. Even more surprisingly, coral reefs can also prevent seafloor erosion through the accumulation of coral skeletons and sediment. Loss of these reefs can cause the seabed to actually sink. So what are the SDGs we want to target? First is the 14th, which helps life underwater, like marine animals, gain a new place to call home amidst human activity. Next is the 9th, in which we want to develop sustainable solutions through innovation.
So, to help address these problems, our group devised a plan called Candy Crush. Now, Candy Crush aims to hit both birds with one stone, those birds being coral reef loss and coastal erosion. Recognizing the fact that coral reefs play a major part in tourism, especially for Indonesia and its coastal areas, we decided to take inspiration from Indonesian cultural elements and heritage, namely, in this case, Candi Borobudur, to add interest but also to give a sense of honor to these cultural objects. And then, in addition, recognizing the way coral reefs work and their key role in the ecosystems of coastal areas in Indonesia, we emulated several elements of the coral reefs and implemented them to our solution by adding features like crevices and large surface areas and other ecosystem building elements from coral reefs to our solution.
For our inspiration of the design of artificial reef, we took inspiration from Candi Borobudur, which is a UNESCO World Heritage Site and one of Indonesia's most recognizable landmarks. We seek to imitate this timeless beauty and intricate design of this historic Buddhist monastery so that people will not forget about it.
Initially, we plan to use aquascape pots stacked up similarly to how the temple is built. Although clay and gypsum is environment friendly and has holes centered to reduce water pressure, the size is too small for most species to enter, and it can potentially dissolve and sway underwater. We tried sculpting it manually, but it was too flexible and thin, especially the tip of the stupa, which can easily break apart. The problem with the design is the sharpness, sudden elevation in height, and pressure is rather increased than reduced, and a vortex forms around the top. So to reduce this with the principle of stability and pressure drag, which is influenced by the pressure stress and friction stress, we increase the surface area and alignment of surface to direction of water flow to prevent backflow, and also reduce the degree of elevation of the tip of the stupa and increase inlets to prevent formation of vortex. Friction stress is highly influenced by fluid viscosity. So we have to produce frictional force to minimize the pressure by making the surface more continuous yet rough or unevenly patterned.
And after the design process, here is our final design. Notice that the individual stupas have their tips removed and they are arranged likewise in a rectangular formation similar to that of the real Borobudur temple. The large amount of stupas also helps with increasing friction, thus breaking the waves. We hope that this design can be implemented all throughout Indonesian coastlines using cheap materials like biomodified concrete or limestone in the hopes that it will help conserve Indonesia's marine wildlife and shoreline.